All right, now let's look at a different problem, which again it's just conversion from one unit to another, but in this case we'll convert time, right? So we have value in seconds and we want to convert that value into days, hours, minutes and seconds. Okay, minutes and seconds. So if you consider a large amount of value which is measured in seconds, right? Let's say 100,000 or something, or even more than that, maybe let's say a million, right? A million seconds. If you have a million seconds, how much is it in days, hours, minutes and seconds, right? Now, as we know, 1 minute equals 60 seconds, right? And 1 hour equals 60 minutes, and each minute has 60 seconds, so this is equal to 60 times 60 seconds, okay, which is actually equal to, if you multiply these, this is 3600 seconds. So there are 3600 seconds in each hour, right? And then one day has 24 hours, and each hour has 3600 seconds. So one day has 24 times 3600 seconds, okay, which is equal to, I think, 86400 seconds, I think. Okay, so this is what you have, right? Now if you have a million seconds, for example, let's say, how would you convert that into hours, right? If you have a million seconds, you divide it by 86400, it will give you some number of days, x days, or it will actually give you x decimal y days, right? Let's say the x is the full days, like 24-hour periods, and the y is, there will be a remainder, right? If it's not perfectly divisible, there will be remainder, right? But it will essentially give you x days, right? And then you take that y, the remaining, which is less than a day, and then you divide it by this number, right? That will give you the number of hours, okay? And then you divide it by 60, and that will give you the number of minutes, and so on and so forth. So in some ways it is very similar to the previous example, which is the the ATM bills, 125 and 1. But in this case the numbers are different, right? We will be doing the same thing, but the numbers would be different. The numbers would be 86400, and then 3660, right? And we always start with the largest unit, right? Even in the previous example, we started with $100 bills, right? And then we tried dispensing $20 bills, and then 5, and then 1, right? Here as well, we'll start with the largest period, which is the day, right? We'll start with day. We'll see how many days does this time period have, right? And then once we get a time that is less than a day, less than 24 hours, we'll try to find how many hours does that make, right? And so on and so forth. So here's how we do it. We have a number. We get a number from the user. Enter a period of time in seconds. The user enters some period of time. We save it in the variable number, right? And then I'm using divmod, but you can use the modulo and the division. We divide the number by 86400, right? And we find the quotient and the remainder. The quotient is the number of full days, right? This is the number of full days, okay? And the remainder is the number of days, the number of seconds which you cannot convert to days, because it's less than this value, right? It's less than 86,400. And once you get that, you update that, right? You div mod it by 3600, and that will give you the number of hours in that time period and the remaining. And for the remaining, you just take the minutes and the seconds, right? And then you print it like so. Okay, so if you run this program, it will look like this, right? So let's say we have a million seconds, okay? we have a million seconds. So we want to find out how many days there are in a million seconds, right? How many days does this make? All we do is we divide by 86,400, right? And that will give us 11.57. So it's a little over 11 and a half days, right? But we know that for a fact that it is 11 whole days and then one half day, right? So this is the half day, right? Now what we want to do is we want to find out how many seconds there are in this number right here in the remainder, because we know that it's 11 days. But what about this? How many seconds are there in this, right? And the way we find that is 1 million modulo 86,400, right? And that would give us 49,600 seconds. So after 11 days, 11 whole days, you still have 49,600 seconds remaining. Now we need to figure out how many hours there are in this number, right? So 49,600. How many hours are there in these many seconds? And the way we find that is just divide by 3,600, right? Because that's the number of seconds you have in 1 hour, right? So when you do this, you get 13, right? Which makes sense, because you see this says 11 and a half days. So half day is 12 hours. We have 13 hours. It's more or less the same, right? So you divide this by 3,600 and you get 13 hours. So now it's 11 days, 13 hours, right? And then you have some seconds remaining. And how do you find that? You do a 49,600 modulo 3,600, right? And that will give us 2,800 seconds. So after 11 days and 13 hours, we still have 2,800 seconds left. So we need to find out how many minutes there are in 2,800 seconds, right? So the way we find that is 2,800, and this time we divide by 60. And that gives us 46 minutes, right? So 2,800 seconds is 46 minutes plus some change. Now that change would be seconds, right? Because after minutes we just have seconds, right? And how do you find that? 2,800 modulo 60, and that will give us 40, right? So the entire thing is this: we have 1 million seconds, which actually is equivalent to 11 days, 13 hours, 46 minutes, and 40 seconds. Okay, and if you want to verify this, number, here's how we do it, right? 11 days, right? And every day has 24 hours, every hour has 60 minutes, every minute has 60 seconds. So an 11 days would have these many seconds in it, right? Now that's 11 days. What about 13 hours? 13 hours will have 60 minutes, which will in turn have 60 seconds, right? Plus, what about 46 minutes? Each minute will have 60 seconds, so 46 minutes will have 46 times 60. And then finally we have 40 seconds, right? Plus 40. If you run this, you get a million. You get a million back, right? So 1 million seconds is equal to this, right? So if I gave you the number of days, the number of hours, the number of hours, minutes, and seconds, you could have easily told me the total number of seconds, right? But the other way around, if I gave you a number of seconds, how would you convert it into days, hours, minutes, and seconds? And here's how we do it, right? We use the integer division and the modulo, right? So if n is the number of seconds, right? Int input, any number of seconds, I don't know what, right? The number of days, let's say d, equals n modulo, right? N integer division 86,400. That's the number of days. And then the remainder r equals n modulo 86,400. Okay, so we have got the number of days and the number of remaining seconds. Now with the number of remaining seconds, we find the number of hours, right? How do you do that? H, let's say hours, equals R, which is the remainder, which is this remainder that we just got, right? R divided by 3600, which is 60 times 60, right? That's 3600, right? So that will give us the number of hours. And then we calculate the change, right? We calculate the change. The change is R equals R modulo 3600. Right? So we update the variable R with the change, right? Whatever's remaining. And then once we have found the number of hours and the change, we use the change to calculate the number of minutes. Let's say M equals R divided by 60, because there are 60 seconds in a minute. And the change is the number of seconds, right? The change is the number of seconds. S equals R modulo 60, right? That's the change. So a modulo is just that, right? Here's what you get plus some change, right? The division, the quotient plus some change. The remainder is that change, right? Anyways, so and then you print, right? So print, if you print d days, h hours, and m minutes, s seconds. So when you run this program and enter some random value, I don't know, and you get the result, right? So this number of seconds, 649,731 seconds, is actually equivalent to 7 days, 12 hours, 28 minutes, and 51 seconds. Okay, so again, it's actually, in theory, it's very similar to the ATM dispenser, except the numbers that we divide in modulo by are different, right? Because the units are different. There we divided by 200 and 120 and 5, but here we divide by 86,400 and 3,660. Okay, but in principle they are the same, right? They are the same problem, different versions of the same problem. Okay,